Hello, dear students. How are you all? I welcome you all to the best platform to study science, that is the Teacher app. So, how are you all doing, dear students? So, all the PCMB, PCMC, and PCME science students. So, I hope you all are practicing your chemistry very well, right? And yes, I know our teacher app is supporting you all in all the forms to make the science course a very easy subject for you, right? So I hope you all are traveling along with our videos. Are you all going through the videos? Yes, along with that, as I told you, the practice of the concepts is also very important. Therefore, dear students, today I have brought a new organic chemistry chapter in front of you, that is amines. So, are you all ready for that? So, watch my video and listen to the concepts till the end of the video. So, it will be definitely very interesting and you will know all the basic concepts about amines chapter. So you have heard the introduction of haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, ketones, and carboxylic acid. And the next organic chemistry chapter will be amines. Once you know the basic of this concept, the further all the things what you study under amines is going to be very nice and very easy for you. So are you all ready for that, my dear students? Yes, let's discuss about more about amines. So what is amines? Have you heard this term before? Yes, amines are nothing but it is to start with amines are nothing but it is a derivatives of ammonia. Students, you all are familiar what is ammonia, right? Can you tell me what is ammonia? Yes, as you know, ammonia is nothing but NH3. Just a minute. So what is ammonia? Ammonia is NH3 molecule, that is nitrogen with three molecules of hydrogen. So you know that ammonia is used majorly in the fertilizers, chemical fertilizers, that is in the field of agriculture, right? So you have heard ammonium and ion and also ammonia, that is NH3 nitrogen atom bonded to three hydrogen atom. So once you are familiar with what is ammonia, then definitely very easily you will know what is amines. Amines are nothing but, dear students, it is derivative of ammonia. Derivative of ammonia means what we do, we just replace hydrogen atoms with any alkyl or aryl group. That means what I do here is, if ammonia is nothing but nitrogen is bonded to three hydrogen atoms, now what I do, I replace any hydrogen atom with alkyl group, that is alkyl group represented as R group, or I replace not only one hydrogen, any number of hydrogen. I can either replace all the hydrogens with alkyl group, or I can replace the hydrogens with aryl group. Aryl group means what? It is nothing but aromatic compound. Then we call these derivatives as, yes, we call these derivatives as amines. So what we do here, students? Ammonia is nothing but NH3, that is nitrogen atom bonded to three hydrogen atom. So when I replace the hydrogen atoms with alkyl group, or I replace the hydrogen atom with aryl group, what I get is amines. Very interesting, right? So how to replace this hydrogen atom with alkyl group? What are the different types of amines we get? What are its property or what are its uses? So studying all this, we study under amines chapter. Okay, so here you can replace the hydrogens, either one hydrogen, we call it as amines, you replace both the hydrogen with alkyl group, or you replace all the three hydrogens with alkyl or aryl group, it will be called as amines. So for example, what I do is, now ammonia, what I do, I replace one hydrogen with alkyl group. So then what happens when you take out one hydrogen, what will be remaining is nitrogen with two hydrogen NH2. One hydrogen I have replaced with methyl group. Then what will be the formula? The formula will be CH3NH2. Or I can replace, if I can replace with ethyl group, then the formula will be C2H5NH2. Right? You can replace the one hydrogen with methyl, ethyl, propyl, any alkyl group. Or I can also, what I can also do is, I can replace two hydrogen atoms. So if I take with two methyl groups, then it will be CH3NH CH3. So what I observe, what you can observe here, students, I have replaced two hydrogen atoms with two methyl groups. Or also I can replace one methyl group and one hydrogen atom. I will replace with methyl group, and another hydrogen atom I will replace with ethyl group, that is C2H5. Also, what I can do, I can replace all the three hydrogen atoms with any alkyl group. For example, I can replace like this. Three hydrogen atom I will replace with three methyl groups like this. So see, number of examples I have written for you, students. See, observe here what I did. Replace one hydrogen atom with methyl group, or replace it with ethyl group, or two hydrogen atoms with the same methyl group, or with two different alkyl groups, or you replace all the hydrogen atoms with alkyl groups. So all this we call it as these derivatives of ammonia, we call it as amines. Also, I can replace with benzene ring as well. So I will get a compound like this, which is called as C6H5NH2. Or if you want me to write a benzene ring structure, it will be benzene attached to one hydrogen atom is replaced with the benzene ring, then it will give you the formula C6H5NH2. See, varieties of derivatives of ammonia, that is varieties of amines we have got, right? So why I have to study about these amines? So why you have to study? Because this amines has an important role to play, right? So where and all you can observe this amines? Yes, amines is present naturally, students. You should be aware of it naturally. Amines are present everywhere in our body as well. It is present in the proteins. Amines are part of proteins. Amines are part of vitamins. Also, amines are present in our hormones as well. Okay, so naturally, amines are part of, or amines exist in our proteins, vitamins, and hormones. Okay, so if you see, if you further in other chapters, when you read about the structure of proteins, or you read about the vitamins and hormones, you see amines or the derivatives of ammonia present there, right? So this is naturally amines exist like this. Synthetically, so where you can see amines synthetically. Yes, students, synthetically you can see amines are used in the preparation of polymers. Okay, so polymers are nothing but different types of polymers you have studied, like nylon, silk, rayon. So this polythene, this kind of polymers what we prepare, amines play role in the preparation of polymers, also mainly in the preparation of any different types of drugs. Drugs are nothing but in the preparation of medicines mainly. So most of the amines are used in the preparation of drugs, also in the manufacture of dyes, different colored dyes. Okay, whatever the colored dyes we use to color any cloth materials or any other materials, the in the preparation of those dyes, these amines are also used. So directly or indirectly, the amines are present naturally as well as in synthetically it is present. As I told, amines are present in dyes. The best example is benzene diazonium salt. We tell it as diazo group. So where you have heard this benzene diazonium salt, can you recall? For example, N2X, benzene diazonium halide. Yes, students, in the preparation of haloarenes, Sandmeyer's reaction, we use benzene diazonium chloride or any benzene diazonium halide. This benzene diazonium halide is also a derivative of ammonia, which is majorly used in the preparation of dyes. Also, it is most of the time it acts as an intermediate to prepare any other organic compounds. That is the use of benzene diazonium salts. That we'll discuss more about this in the further live sessions. Okay. And also, students, there is one of the important anesthetic drug. Okay, an important anesthetic drug known as Novocaine. So this anesthetic drug, what is this Novocaine? It is an anesthetic drug which is used mainly in dentistry. Mainly when you go for any root canals or anything related to dentistry, right? The dentist will give you an anesthesia, which is Novocaine. Novocaine is a made up of amines. It is made of amines, okay? That is given as an anesthetic drug. See, most of the time, this why I highlighted this will be asked in the exam, and most of the time what students think is maybe it has come from chemistry in everyday life chapter. No, this question actually would have it comes from amines. Okay, which component or which organic compound is present in the synthesis of Novocaine? It is nothing but amines will be present. So like that, there is a lot more applications of our amines directly or indirectly in our daily life, right? So understood, my dear students. So it is clear for you all what is amines now. So let's move on. Now you understood what is amines. What is the structure of this amines? How it exists three-dimensionally, or what is its hybridization? All that we have to know. You all know that the structure of ammonia, right? Ammonia has pyramidal structure with three hydrogen atoms. The structure of ammonia is pyramidal, and also it has one unshared pair of electrons, right? You remember the structure of ammonia, the pyramidal structure with unshared pair of electron. The same way, the derivatives of ammonia, that amines, what is the hybridization of amines? If you observe what I do here, I just replace with alkyl groups, right? The structure remains the same, that is pyramidal structure. Now for example, if I replace with three methyl groups like this, and also it will be having an unshared pair of electron. You take any of the amines, for example you take RNH2. The nitrogen atom here will be having one unshared pair of electron. You replace with two alkyl group, then what you get? RNHR, two alkyl group. The nitrogen will be having a one unshared pair of electron. Or you replace with three alkyl groups, then also the nitrogen atom carries one unshared pair of electron. That means what you can observe, the nitrogen atom, if you observe the hybridization, it will be having bond pair plus it also has lone pair. Correct? So how many bond pair electrons? Nitrogen atom is bonded to 3 atoms totally. So 3 bond pair and 1 lone pair. So totally it is 4. So 4 means what will be the hybridization, my dear students? Yes, as you all know, the hybridization is sp3. Okay, so the hybridization of amines is sp3 hybridized. So how did you all understand how it is sp3? Because the nitrogen atom is bonded to 3 bond pair of atoms and you can see 1 lone pair. So the total it is 3 plus 1 4. So you know that if it is sp3 hybridization, what do we expect the structure to be? So if it is sp3 hybridization, we expect the structure to be tetrahedral, right? So tetrahedral with a bond angle of 109 degree 28 minutes. This is what we expect the structure for sp3 hybridization. But here, don't think ammonia the structure is sp3 yes, it is sp3, but don't think it is tetrahedral. The structure of ammonia or derivatives of amines is pyramidal structure. So pyramidal, see, the hybridization is sp3. See the orbital here, the orbitals will be is 4 sp3 hybrid orbitals. You can see 4 sp3 hybrid orbitals bonded to alkyl group. sp3 orbital of one sp3 orbital of nitrogen, another sp3 orbital, here another sp3 orbital, and here another sp3. 4 sp3 hybrid orbitals, the orbitals of nitrogen overlap with the orbitals of the alkyl group, whereas the fourth, see once again I'll write here, this is one sp3 hybrid orbital, this is another sp3, and here you can see sp3 hybrid orbital. There is 4 sp3 hybrid orbital in alkyl in nitrogen atom that overlap with the alkyl groups, whereas the fourth sp3, this one, the fourth sp3 hybrid orbital has the unshared pair of electrons in it. So what the fourth sp3 hybrid orbital has? It has unshared pair of electrons, giving the bond angle here becomes, so you can see what is the structure here. It shows a pyramidal kind of structure. So because the bond angle here will be 108 degree. Is it clear? So, nitrogen atom of amines is trivalent, not tetravalent. It is trivalent where the fourth sp3 hybrid orbital carries unshared pair of electrons. So, the hybridization will be sp3 but the structure will be pyramidal. Is it clear, my dear students? So what will be the bond angle between the carbon, nitrogen and the alkyl group? The bond angle will be 108 degree, not 109. Yes. Now we will go to the classification. See, these are all the introduction. What I am giving is introduction to the chapter amines. And you want to know in depth? To study in depth, what you have to do? Yes, quickly you have to download the teacher app. I hope you all have downloaded in your Play Store the teacher app and you are going through all the recorded videos, all the live sessions, all the subject. Are you following, my dear students? Yes, I think along with your syllabus, every day when you're following your the videos that is uploaded, it will be helping you a lot, right? Yes. So this introduction and the in-depth studies, you all the videos of the amines chapter is given in your teacher app. Okay. So let us go through the classification. How can we classify amines? Yeah, we can classify amines into 1 degree, 2 degree or 3 degree, which is otherwise called primary, secondary or tertiary amines. On what basis? On what basis we classify amines as this primary amines, secondary amines and tertiary amines? It is nothing but it is based on how many hydrogen atoms you will replace with alkyl or aryl group. Now, for example, you know that nitrogen is ammonia is having three molecules of nitrogen trivalent. Now, first what I do, I replace any one of the hydrogen atom with alkyl group. So what I get? If I replace with methyl group, I will get CH3NH2. So how many hydrogen atom I replaced? Only one hydrogen atom. Then this is called primary, or in short we represent like this. This is an example for primary amine. Or you replace one hydrogen atom with aryl group also. What you get? You will get, yes, C6H5 NH2. So this is also an example for primary amine. Now, if I replace two hydrogen atoms with any alkyl or aryl group, then for example, if I replace two hydrogen atoms with methyl group, what I get? I get CH3 NHCH3. So what I did here, I replaced two hydrogen atoms with two methyl group. Then this is an example for secondary amine. Is it clear? Now next what I do, let me replace three hydrogen atom with alkyl groups. All the three hydrogen atom I'll replace with alkyl or aryl group. Now for example, if I replace all the three hydrogen atoms with methyl group, I may get a compound like this, right? So what does it mean? So this is an classification of tertiary amines. Is it clear, my dear students? You are all understood what is primary amine, what is secondary amine, and what is tertiary amine? It is based on how many hydrogen atoms you will replace with alkyl or aryl group. So if you replace one hydrogen atom, we call it as primary amine. If you replace two hydrogen atoms with alkyl or aryl group, it is secondary amines. And if you replace all the three hydrogen atoms with alkyl or aryl group, it is called tertiary amines. And this is how we write the general representation of primary amine, secondary amine and tertiary amine. This is how we represent in general. So once we have understood what is amines, what is the application of amines and how does it appear, what is the structure, what is the bond angle and what is its hybridization, how many bond pairs amines has, how many lone pair it has, and also what is primary amine, what is secondary amine or what is tertiary amine. Next thing what we have to understand is the nomenclature part, the very important part. Any compound is synthesized. What we have to do? We have to do the naming ceremony, right? Naming ceremony is nothing but nomenclature. So in chemistry language with the naming ceremony we call it as nomenclature. All these different types of amines, primary or secondary or tertiary, need some names, right? What names we follow? Yes, IUPAC nomenclature, but let us discuss both the common name and as well as the IUPAC name. First, if we try to name amines in common name, because sometimes you have to know the common names also. Okay. For example, let me take an example. Simple amine. Let me start with a simple amine, that is CH3NH2 primary amine. You know that I have replaced the hydrogen atom with methyl group. So simple way I can name this as methyl amine. This is a simple way of representation in common name. Which alkyl group? So in general, I'll tell you in general, for all the other compounds you can name. In general, we call it as alkyl amine. This is how the common name we represent amines as alkyl amine. So if I replace with hydrogen atom with ethyl group C2H5NH2, how do you name it? You name it as, yes, you name it as ethyl amine. Yes, this is for primary amines. What if it is, what is a common name for secondary amines? So, if it is a secondary amine or tertiary amine, we use the terms di, tri. So, we use these terms. For example, let me write an example of secondary amine. How do you name this secondary amine? Yes, there are two methyl groups. I use the term di. So, dimethyl amine. Is that clear? So when there are two alkyl groups, you use the term di. So it is dimethylamine. If you replace all the three hydrogen atom, let me write an example of tertiary amines. Okay. So if it is tertiary, which term do you use? Yes, you use the term tri. So the common name for this compound will be trimethyl amine. Is it clear? So this is a simple way of representation of amines, common name. So you just represent it as alkyl amines. So if it is primary amines, you name it as the particular alkyl group, you will name it as methylamine, ethylamine. And if it are two alkyl groups, secondary amines, you use the term dimethyl, diethyl. Or if it is tertiary amines, you use the term trimethylamine or triethylamine, like that. What if, see students, in this amines, we can classify amines, the secondary amines or tertiary amines as simple amines and mixed amines. What is this simple and mixed? If you, the two alkyl groups what you are substituted is same, like this dimethylamine or trimethylamine, we call it as simple amines. Whereas if it is two different alkyl groups, like this, I'm writing one example, you can observe here, CH3NHC2H5, so we call this as mixed amines. Now, how to do a common name? How to give a common name for mixed amines? That is again very simple. I can call this as ethyl methyl amine. Okay. So, in a common name, I can name this as methyl ethyl amine. That's it. This is how you give a common name to the amines. So, in general, you can call it as alkyl amines. But you know that most of the time we have to follow IUPAC nomenclature, that is given by International Union of Pure and Applied Chemistry. So any corner of the world you go, this IUPAC nomenclature will be followed to name any compounds or any organic compounds. So what this IUPAC system is following? Yes, that is the best thing or the first thing that you have to know. IUPAC, according to IUPAC system, any amines in general, it is named as alkanamines. Okay, it is not alkyl amines, it is named as alkanamines. For example, see, in common name it was alkyl amines, whereas in IUPAC nomenclature, well, how do you name it in general? Alkan amines. Understood how it is, my dear students? See, for example, how do you write alkane? Alkane, A-L-K-A-N-E. Very simple. What you do? Just remove, erase E and add amine. That's it. You have to erase E from alkane and add the particular amine. That's it. For example, what is CH4? What is CH4, my dear students? You know that you will write CH4 as methane. But I have methyl group here, CH3NH2. So how do you write this, the name of IUPAC nomenclature for CH3NH2? So yes, methane, just erase E and add the term amine. So it is methanamine. Is it clear? Now if it is ethyl group, C2H5NH2, how do you name the ethyl group, my dear students? Can you try naming ethyl group now? Yes, what it is? Two carbon atoms. Two carbon atoms means ethane. And what you have to do? You have to erase E and add amine. So what will be the answer? Yeah, the answer is ethanamine. Right. So now you have a best idea how to write the IUPAC and also the general name, common name, right? Okay. Now what I'll do is I shall put some examples in front of you. You have to try to give the IUPAC nomenclature for that particular amines. Okay. Are you ready for the task? Fine. Now let me write CH3, CH2, CH2NH2. So how do you name this compound? Yeah, you are ready to answer, I know. Also, let me put another example. Are you able to make out the difference here, dear students? Yes, the first one also it is propane and second one also it is propane because both contains three carbon atom. But what is the difference there? The position of NH2 group varies, right? So when from propane, since the position of NH2 group will vary, I will denote that with numbering the carbon atom, right? So you have to start numbering from here where the NH2 group starts. Here it is 1, 2, 3. So how do I name this compound? I will name this compound as propane. You should erase E. Where is the position of NH2 group? In the first position. So it is propane 1 amine. Is that clear? So this is how you do the IUPAC nomenclature. So you have to first number the compound from the propane derivative. And here you can see the position of NH2 group is, the NH2 group is attached to second carbon. Therefore, here I will write the name of the compound as propane 2 amine. Is it clear, dear students? So here the name of the compound is propane 2-amine. Whereas this is about the primary amines. Now let us see how to do the IUPAC nomenclature for secondary or tertiary amines, and also if it is a mixed amines, how to name it. For example, let me take, so this is secondary amine, you know, and also I'm taking the example of mixed amine. So a common name, you know, it is easy, ethyl, methyl amine. This is how you name. Whereas here there is no, here you don't have to number, but how do I write the name of this compound is, this I will consider. This part I will consider as a main group or the parent chain, number one. Whereas this one I will consider as a substituent. So I will write to the N-methyl. So here methyl group I am considering as a substituent, and I am giving the preference or the parent chain as a to the ethyl group. and that is, sorry, yeah, ethyl group that is having more number of carbon. So I will write it as N-methyl ethanamine. Is that clear? To the amine derivative, that is the nitrogen atom, methyl group that is attached, I am taking as a substituent. Therefore, the name goes out like this, that is N-methyl ethanamine. Is it clear? So, what if it is, you can take a note of it, dear students, okay? You can make a note of it or you can take a screenshot, and after once you have understood, you can try to you can write more and more example and try to do the IUPAC nomenclature. Follow all these rules and you can try writing the IUPAC nomenclature. This is in case of secondary amine. I gave you the example. Now let me take any tertiary amine. For example, if I take tertiary amine like this, so how do I give the IUPAC nomenclature? Here numbering is not required. When you have to number is when the amine group, that is NH2 or NH group, is attached to different positions of the carbon atom, you have to number. Whereas here three alkyl groups is attached to the nitrogen atom, right? So one I will take it as a parent chain, the other two you have to take it as a substituent, and yes, you have to use the terms like di, tri, those terms you'll be using. So here I will write the name of the compound as N comma N. How many methyl groups? Two methyl groups. So N comma N dimethyl, dimethyl, the parent chain. Yes, dimethyl methanamine. Is that clear? So this is how you do the IUPAC nomenclature for amines. It is N comma N hyphen dimethyl methanamine. Is it clear, my dear students? So you have to try to solve more and more example like this. What if in case of substitution with aryl group? How do you do the common or IUPAC nomenclature for aryl group? So students, if it is aryl group, let me start with a simple example where to the benzene ring NH, yes, benzene ring is substituted with replacing one hydrogen atom, you will get C6H5NH2. The common name of this compound is aniline. Okay, so commonly the compound where benzene ring with NH2 group is called as aniline, whereas how do the IUPAC nomenclature? Yeah, benzene ring, raise E benzenamine, right? The IUPAC nomenclature of the compound will be benzenamine, but students, most of the time we don't use the term benzenamine in both the, whether it is a common name or IUPAC nomenclature, we write it as aniline only. We use the term aniline most of the time. So this is what followed. Yes, benzenamine is correct, but we follow the name aniline most of the time. Okay. Now for exam, one more compound I'll give you. You will try to name the compound. Okay. So how do you name this compound where bromine is attached to the bromide ion is attached to the fourth position or the para position? Yes. If it is a common name, you use the term ortho, meta, para, right? So I write it as para bromo aniline. Whereas when you are doing the IUPAC nomenclature, what do you have to do? You have to number it, right? So you can write it as 4-bromo aniline or 4-bromo benzenamine. So the name of the compound will be 4-bromoaniline or 4-bromobenzenamine. Is it clear? So I hope it is clear, my dear students. What you have to do? You have to just remove erase the E and retain all the other alphabets and just add the particular amines to that. So let us recall quickly what we have studied in this session, in today's session. So you all are thorough with the introduction part of amines chapter. Why we have to study more and more about amines? Because as I told you, natural way, in synthetic way, knowingly or unknowingly or directly or indirectly, amines is part of us. Right? It is present in different ways along with us. So you have to study about amines because of the lot of application it has in our daily life. So and you understood what are amines. It has nothing but derivatives of ammonia. You replace the hydrogen or atoms of ammonia with alkyl or aryl group, you get n number of different types of amines. And also the structure of amines, even though the hybridization is sp3, it shows pyramidal structure. Why it is pyramidal structure, I have explained in this session for you. After that, you all understood the classification of amines, what is primary amines, what is secondary amines, and tertiary amines. The classification part is clear for you all, right? After the classification, the very important part of the amines is nomenclature. How to name the amines in a common system, also how to name the amines in a IUPAC system, I hope is clear for you. And I hope this session has helped you a lot to understand all the basic things necessary to further study amine chapter. So once again, you can go through the video from the beginning to the end. Listen to all the basic terms, dear students. And definitely, I know this session will be helping you a lot to further make this amines chapter very easy for you. I'll once again meet you all with some more concepts like preparation of amines, its physical properties or what it is, its chemical properties it will show. Let us discuss more and more about amines in further upcoming sessions. I thank you all for being with me. Yes, thank you all, my dear students, and all the very best to you all. Okay.